Hello. So I have been given a volume function, f of x, and the problem as described says that the volume of the box, f of x, is based on the length, x in this case. And so I've been asked to draw a graph that's on the grid to the left and to do a couple things, one of which is to use the domain and the range to aid me in drawing the graph, but also to label the axes as well. So why don't I label the axes first, because that's probably going to be my easiest step. X, as you can read on in the problem, x is my length, and y is my volume. And y, as you know by now, can be written as f of x, or a function of my length. And so let's talk about domain for a moment. Domain is the range of all the possible values of x, or all the possible lengths that I have. So just by looking at the function, I can see that I don't think that there is a value of x in which the function is undefined. So therefore, the domain is all real numbers in this case. The range, again, if I were to graph the function, or if I were to try and come up with all the possible values of y, I don't think that there is one in which there's a value of f of x that cannot be attained. So therefore, it's going to be all real numbers as well. And I'll just even write that symbol down. Okay, so let's start graphing our function. So earlier on, when I last solved this problem, one of the steps is to identify all the zeros. So in order to do that, I had to actually factor the problem out. And therefore, I had to, and I'm just going to walk through this relatively quickly. I know that I can factor out an x from the function to get x squared plus 2x minus 8. And this trinomial inside the parentheses can be further reduced into x plus 4, x minus 2. If you don't know how I got from this trinomial to these two binomials, then it might be an opportunity for you to review factoring trinomials, the FOIL method, those types of references to be able to get to this point. All right, now from here I can see that my three zeros, as shown by these three terms and expressions, my zeros are going to be 0, -4, and 2. Therefore, I immediately know three of my points on the graph. 0, 0, at 2, and at -4. So I know where the zeros are. Now, the question is, well, how do I know what the graph looks like exactly? Well, and this is where I will need to build a table of some type to be able to find my other points. So I know that there's going to be three different intervals at the zeros that I'm going to be specifically checking. The first interval is from -4 and then values that are less than -4, between -4 and 0. 0 and 2, and then values that are greater than 2. So for this, I'm going to make myself a t-table of sorts, just to help me out. All right, so let's start with values that are to the left of -4, like -5 and -6. So if I took -5 and I put that into my function, I get a really, really large negative number. So it looks like I'm going to start drawing what this looks like. It's probably going to be down, way down, because I got -35 at point -5. So that line might even be a little steeper, that black line. All right, now between -4 and 0, well, let's see. -3, the point, if I plug that into my function, -3 cubed plus 2 times the quantity of -3 squared minus 8 times -3, I end up getting 15. So I'm actually going to fill out the values that I got. So -5, I got -35. For -3, I had 15. So that's up here somewhere. So that means my line is going to go up like this. All right. So I don't know what happens yet, but I know it's going to come down at some point because, again, I know that it hits 0, 0. All right, now let's look at 1. So what if I put 1 into my function? What's going to happen? Well, let's see, 1 cubed plus 2 times 1 squared minus 8 times 1, I end up getting -5. So 1, -5 is down here. So that means the graph goes down and then it has to come back up. And then what about when x is 3? What happens? Well, when x is 3, my y is 21. So this is when I know my function goes up like this. I'm sorry that it's a little messy. Why don't I erase that to give you a better idea of what this looks like. All right, so now you kind of know what the shape looks like, because all I'm doing is plugging in values for x immediately to the left and to the right of the 0. Okay, so I'm going to put my zeros back in. 0, -4, and 2. And so my function is going to look something like this. -5, -35 goes down like that. And then it comes back up, goes down to 1, -5, and then it comes back up like that. And so that's a graph of my function. All right, so that finishes that step. Now, one other question was explain the significance of the zeros in relation to the size of this box. Well, if I plug in these zeros into my volume function, I get a volume of 0. And so the significance as entered, the significance that I would answer or reply back would be these are the points where the volume is 0. Therefore, the size of the box does not have any sort of existence at this point. However, these function as boundaries, if you will, for my possible values of my length. And so let me rephrase that a bit. These are just values where the volume is 0. However, these zeros give me an ability to be able to see what the actual values of length could be. Particularly between -4 and 0, this is a possible range for my length, and then after 2 as well.